first speaker you just met is Steve Barrett. He's Product Director for W.O.C.s Water Technologies. Steve has been associated with the plumbing, heating, and refrigeration industries for more than 25 years in various sales, marketing, and product management capacities, and he has been a significant contributor in the areas of new product development and product commercialization. Steve is currently responsible for the product management of W.O.C.s Potable PEX, residential fire sprinkler, quick connect, and brass and tubular product categories, as well as the development and commercialization of the company's new Trident radio frequency fusion weld pipe and fitting product line, which is the topic of Steve's presentation this morning. Steve received his Bachelor of Science degree from the Indiana University of Pennsylvania in 1987 and has since held management positions with Superior Valve Company, Armstrong Pumps, and W.O.C.s Regulator Company. Now, here to tell us about potable and process pipe and fitting advances utilizing radio frequency fusion welding techniques, please welcome Steve Barrett to the podium.
Good morning, ladies and gentlemen. I know it's a long title, Potable and Process Pipe and Fitting Advances Utilizing Radio Frequency Fusion Welding, but this morning I'm going to talk to you about how to zap pipe. As was mentioned, I am with the W.O.C.s Regulator, or W.O.C.s Water Technologies out of North Andover, Massachusetts. Briefly, W.O.C.s Water Technologies has been in the industry since 1874. We started out making pressure and steam regulators for the textile mills in Lawrence, Massachusetts. Today, W.O.C.s is a little over $1.4 billion in annual sales. We manufacture in both North America, China, and Europe. We operate on 4 strategic platforms, primarily residential and commercial flow control, HVAC and gas, water quality, and most recently, water reuse and drainage. Our products range from the standard multi- and quarter-turn ball valves and things of that nature, to pressure and temperature relief valves, to tempering devices, backflow and drainage products, and again, most recently, plastic pipe and rainwater collection and reuse systems. In 2005, plastic pipe outstripped metal pipe as the primary conveyance conduit for potable water. As you can see, for years and years and years, it was metal. It was primarily copper and iron. And then in 2005, plastic pipe, primarily CPVCs and PEXs, took over the market. And it continues in this manner and will continue on in this manner. You know, as our housing markets, our housing and commercial markets rebound and municipal infrastructures continue to be addressed, plastic pipe will continue to be the material of choice, primarily because of the material, labor, and installation cost benefits that it provides. And in 2014, the EPA is also mandating that all components of the potable plumbing stream be offered in lead-free materials. And if anybody has had any interface with lead-free metals, they are very expensive. And in this vein, we're going to continue to offer, or we will offer, a full line of lead-free metal valving and componentry, but we're also doing a lot of heavy research and work on the plastic variations of these items as well. North America today, these are the primary uses of plastic pipe. In potable, and when I refer to potable under 3 inches where I am, is primarily controlled with PEX, which is cross-linked polyethylene, and CPVC. In 2012, in 2013, next year, you'll see the advent of different blends of polyethylene, primarily PERT pipe will hit the market. In geothermal, plastic pipe is all that is used for geothermal right now. Potable over 3 inch continues to be replaced by plastic. You see a lot of municipal infrastructure, whether it's new or replacement, is continuing to move towards plastic pipes. Irrigation is a primarily plastic market. And within the last 10 or 15 years, natural gas has made that shift as well. And more natural gas conduit is being laid with plastic pipe. Today's joining methods, there are basically 4 on the market that are available. Each has its pluses and its minuses. The first mechanical is what's been used for a very long time. It includes the crimps and the compression type fittings. Concerns in this area continue to be leaks. Flow, especially when you're talking about an insert fitting, primarily with PEX, is reduced because you've taken the idea of the pipe and placed a fitting inside. And joint integrity across the market tends to be inconsistent. Solders and glues, long-term joining methods, also have their pros and cons. Well, they do allow for full flow of the pipe. The installation cost tends to be high. Concerns, especially with the copper industry, is the introduction of flame. There are many insurance companies that will not underwrite construction using flame joining techniques now. And the joint integrity is highly skill dependent. Butt weld is a primary joining method in geothermal and irrigation right now. It is highly labor and skill dependent. It is also highly dependent, the integrity of the joint is highly dependent on the ambient temperature. Concerns, one of the largest concerns in this joining method is, believe it or not, installer burns. The installers tend to be directly in proximity to the heating mechanisms, and a slip can cause you a 3rd-degree burn very quickly. The joint integrity, again, is highly skilled labor dependent. And lastly, electrofusion, which tends to be used more on larger diameter and also where the joint it must perform. It is designed for no leaks at all. However, it is a very expensive joining method, and the skill set has to be very high. I really want to talk to you this morning about radio frequency fusion welding. RF fusion welding has been used in the pipe joining industry for a long time, primarily larger diameter pipes, again, where that integrity of the joint is critical. We've worked with a few industry folks to come up with a radio fusion welding techniques that basically brings radio fusion welding to the plumbing and heating contractor at an acceptable cost level, and an installation technique that can be used with little or no training. Just to talk real quickly about what radio frequency fusion welding is. It's a method of joining the pipe where you basically melt both ends of the fitting and the pipe, and you create a hermetic outside diameter seal. AC power is delivered to a power converter, and it is then converted into a DC high frequency current. The current is then sent to a fuser, which is the handheld piece of the device, and it's transformed directly into a high frequency magnetic field. The beauty of the system is that you get heat on both the positive and negative fluctuation of the radio wave. We place a dual susceptor device, which in this case is a ferrous metal ring that is overcoated with the base material and magnetic particles. The frequency that we operate this system at is an IMS band, which is Industrial, Medical, and Science. It's a band dedicated worldwide to that part of the industry. The ring is placed into the magnetic field, and the opposing high-frequency current is developed, and it generates heat using the ring's natural resistance. What you're looking at right here is actually the susceptor ring as it's being heated with the electromagnetic wave, or with the radio fusion wave. As I mentioned, the susceptor ring is metal. It's ferrous itself. It's embedded into a fitting. We also, through this process, realize an additional action, and that's magnetic hysteresis. And it causes magnetic particles in the ferrous ring to rub against each other and actually create a heat analogous to friction. So when you take the magnetic flux and you introduce it to the susceptor ring, it creates heat. And the photograph to the right is an actual photograph of the ring while it is being heated inside of the fitting. Oops, excuse me. So why RF fusion welding for fluid and gas distribution systems? Our contractors, system design engineers, civil planners, and codes officials are demanding a fitting and joining system that addresses the following concerns in one package. Performance. The fittings have to flow. The fluid that goes through the pipe should be at the ID of the pipe. They are also looking for a strong, permanent hermetic seal at the fitting. Value. They're looking for a system that provides cost-effective material, labor, and installation and long-term maintenance costs. Safety. Provides a system that is safe and easy to install. As I mentioned, there are many injuries throughout the industry through exposure to heat from flame, heat from exposed heating coils, and also from exposure to V.O.C.-based glues and solvents. And lastly, environment. We need to provide a system that is environmentally sound and can be recycled during its life cycle. Polyethylene pipes and fittings have the ability to be recycled during their manufacturing process, and most importantly, after their manufacturing or their service life processes. What we've developed, we refer to as our Triton Electrofusion welding system. It is a compact welding and fitting system that addresses each of the market concerns that I laid out. The unit operates at 120 volts. It's a VAC power supply. It converts the power, and the draw on the power is less than 100 watts, significantly lower than other fusion welding systems that are on the market. The system also provides for a fuser, which is the handheld device that actually welds the pipe. Both the fitting and the pipe are permanently hermetically welded at the end of the process. As you can see here, the fuser on the right is a handheld caliper. The fitting system itself is made up of the pipe, polyethylene pipe, the dual susceptor, which is the magic in the fitting, and the fitting itself. Performance. The Triton welding system will work with any thermofusible plastic. Our preliminary take will be on polyethylene, since polyethylenes dominate the plumbing market right now. But it also will work on polypropylene pipes. The system is scalable. We can take it with a 110 volt system up through 10 inches in diameter, so it'll be able to address the municipal infrastructure market. The fitting is made from the base material, so from a recycling standpoint, both the pipe and the fitting itself are recyclable. As I mentioned, we can scale this up through 10 inch with only a moderate increase in the power supply. The process itself creates a very strong hermetic shear joint. The system allows for full flow on the pipe. You're making a seal on the outside diameter rather than the inside diameter of the pipe. And the burst strength of the fitting is far in excess of the pipe itself. Go back one. From a value standpoint, The system itself is accessible to the plumbing and heating contractor as we see them today. This is not an exotic system or an exotic joining method. The installation time is actually fairly reduced when compared to reduced when compared to a glued method or a soldered method joining. The system itself with plastic pipe tends to be run in much longer lengths and therefore reduces the need for fittings at each turn of the pipe. The system itself can be done and tested within 25 seconds. The entire system can be dry fitted. And lastly, it's polyethylene pipe, folks. There's not a big market for it at the scrap dealers, and it definitely is not something that thieves tend to look for at job sites. From a safety standpoint, the system itself is protected by a ground fault interrupter. The unit itself will not engage until it recognizes the dual susceptor, so that it cannot arbitrarily be put around a screwdriver or a wrench and the circuit won't flow. It generates no external heat or EMFs. The fittings themselves can be handled immediately after the welding process, and all the components meet or exceed the UL and OSHA standards. From an environmental standpoint, as I mentioned earlier, the resins used in both the fittings and the pipe are recyclable and do not enter the waste stream as landfill. The energy draw on the unit itself is less than 100 watts, very economical from an electrical standpoint. The full flow fittings allow for sizing variability, where a crimp system may require a 3/4 or 1-inch pipe to provide the flow to the fixtures. Using this system, you can go to a lesser sized pipe and still achieve your flow requirements. The hermetic seals go a long part in elimination of leaks, and this is particularly important to the irrigation industry, where hundreds of thousands of gallons of water are spilled every year trying to get water from point A to point B. And the system itself eliminates open flame joining systems and exposures to V.O.C.s. In summary, the worldwide demand for plastic pipe and joining systems continues to increase dramatically for both new construction and municipal infrastructure replacement. System designers, engineers, contractors are calling for plastic pipe systems that meet key initiatives that focus on performance, value, safety, and the environment. By manipulating known principles of radiofusion energy transfer and incorporating advanced manufacturing techniques, a system for joining thermofusible, potable, and processed pipe has been developed that meets and exceeds today's common joining methods. Any questions?
How much does the unit cost?
The unit will cost less than $1,000 to the contracting community, which puts it in the same wheelhouse as a crimp or a crimp or a butt fusion welding system. So it'll be immediately accessible to the common contracting community.
So, excuse me if I can follow up. So in order to diffuse the polyethylene now, or with this machine, you have to have a proprietary coupling with it?
It will be proprietary, yes, sir.
Okay, and all the other fittings are going to be proprietary?
And all of the fittings will be proprietary as well.
Sold by Watts?
Sold by Watts.
Okay.
Is the piping compatible with all the standardized pipe that are polyethylene pipe that are available on the market today?
Yes, sir. The base material, the base resin that will be used on the for the couplings, or I'm sorry, for the fittings, will be a polyethylene based. At least in the very beginning, though, we're already working on a polypropylene based and a nylon based fitting system as well. So the pipes are already on the markets. We're not reintroducing a new pipeline to the market.
You mentioned that you can dry fit the system and then come back and if you want to say weld the fittings at a later time.
Yes, sir.
What about ambient moisture or ambient temperature? Is that a problem if moisture gets into that socket of the fitting?
Most typical dry fits are going to happen inside of a structure, inside of a building. So from an ambient moisture position, I'm not sure that there's a big worry. The fitting system and the welding system is fairly reliable. I would say that if you're in a damp trench, you'd want to wipe the pipe and the fitting anyway. But we have welded in damp atmospheres, and it seems not to be an issue.
Thanks.
Steve, what would be the training learning curve?
I mentioned that the skill set is certainly going to fit into a general contractor or a general plumber. We would recommend that the contractor goes through it would be a 90-minute training process, and that is going to be primarily how the electronics work, how to deal with any problems that you may incur. But from a dry fit perspective, or from an installation perspective, as long as the contractor or the installer knows where the wand goes on the fitting and how to press the button, it's fairly straightforward.
I'm kind of intrigued also by the origin. I guess we're used to seeing some of these pipe joining methods coming in from overseas. Mm-hmm. Can you just address where the origin of this?
Certainly. Fusion welding pipe has been around for a long time, and there are really two basic methods, and one is butt welding and one is electrofusion. And butt welding is simply heating the pipe and the plastic fitting and joining them together. It's a fairly reliable method of joining pipe. The drawbacks to it is that the mandrels that heat up that are used in the fitting, and this is worldwide, is an exposed heated mandrel, and they operate in the 500 Fahrenheit range. I was at a show a few months ago, and actually a geothermal show. Pardon me, and a contractor came up and asked if I wanted to see his credentials for butt welding, and I said absolutely, and he rolled up his sleeve and had his cigarette burns all the way up the sleeve from where he'd slipped off the welding iron and branded himself. From an electrofusion standpoint, the wire is embedded in the fitting system. It's a very strong joint, very reliable, very expensive joint. And from a manufacturing process, the fitting itself is difficult to make. You have to take the plastic fitting that you're dealing with and you embed wire, and then you electrocute it, kind of like a Frankenstein's laboratory method. So it's been around a long time, and the electrofusion or fuse welding in Europe has been around much longer than it has in North America. The Europeans tend to be about 20 years ahead of the fitting and pipe adoption cycle for plumbing and heating. This kind of came out of the blue at us. We were introduced to a company who actually presented here several years ago, or 2 years ago, who had an interesting idea of taking radio fusion, which is used primarily in joining plastic shapes, not necessarily round shapes in the industry, and it tends to be more of a capital equipment venture. And they had a kind of a bright idea that, hey, we join squares and ovals and triangles made out of plastic. It would certainly work on a circle. And we had some preliminary talks with these folks and said it's a great idea, but it's only going to be a great idea if we can get it to the market, if we can get it to the contracting community. So that's where it evolved.
Very good. Do we have any last questions for Steve?
Yeah, I have a question. You talked about dry fitting. Is there a way to visually distinguish the fused fitting from the unfused fitting?
There is. We did a tremendous amount of V.O.C. with contractors in North America, and that was one of the things that they brought up first and foremost is the ability after you've dry fit, or really after you've made the connection, to know whether you've made the joint. We have a patented device on the fitting, actually embedded into the fitting, that we call the weld tell. And basically what it allows the contractor to do is it's a dimple in the fitting, and if you get an opportunity to stop by, I'll show you directly. But in the unwelded condition, it looks strictly like a dimple in the fitting, and after you do the welding process, it actually extrudes from the fitting, so that you get both a visual and a tactile notification that the fitting has indeed been welded.
Very good.
Well, again, thank you very much. I appreciate it. And if anybody would like to see the system actually operate during the breaks, please stop by and see me.
Thanks, Steve.
Thank you.